At 4 o'clock in the morning, the sky above Dubai suddenly lit up. A slow-moving drone slipped through the darkness. Moments later, a fuel storage tank near Dubai International Airport erupted into flames. Flights stopped. Roads closed. Emergency crews rushed toward a towering column of fire. This was not a missile strike. It was not a stealth aircraft. It was a cheap propeller drone. And it was only one of thousands. Since late February, Iran has reportedly launched more than 2,000 drones and missiles across the Gulf region in response to United States and Israeli strikes. The attacks have targeted American bases, oil facilities, ports, and airports across several countries. Many of those weapons were a specific type of drone, the Shahed, a weapon that costs a fraction of a modern interceptor missile. But when launched in massive numbers, it can overwhelm even advanced air defenses. And that is the real story here. Because the drone that struck near Dubai International Airport on March 16 was not just an isolated attack. It was part of a strategy built around swarm warfare. But here's the bigger question. If these drones are slow, if they are noisy, if they are relatively easy to detect, how are they still getting through modern air defense networks? To understand that, we need to step back and look at the weapon itself. The Shahed series of drones was developed by Iran during the past decade as part of a broader effort to create low-cost precision strike systems. Iran faced a major military problem. It could not match the advanced aircraft fleets of countries like the United States or Israel. Building a modern air force requires decades of development and enormous financial resources. So Iran invested in a different strategy, asymmetric warfare. Instead of competing aircraft for aircraft, Iran focused on missiles, drones, and proxy forces, weapons that could be produced cheaply and launched in large numbers. Among those systems, one platform became especially important, the Shahed 136. This drone is often described as a loitering munition, but in practical terms, it functions more like a small cruise missile. It is launched from a rack or mobile launcher. Once airborne, the drone follows a pre-programmed route toward its target. And when it reaches the target area, it dives directly into the objective and detonates, which means the drone itself is the weapon. There is no returning home, no landing, only impact. The design of the drone is surprisingly simple. It uses a triangular delta wing shape, a rear-mounted propeller engine, and lightweight composite materials. The result is a drone that can travel hundreds of miles at relatively low altitude. Typical speed is estimated between 150 and 190 kilometers per hour. Slow compared to missiles, but fast enough to reach targets across the Gulf. The range can exceed 1,000 kilometers depending on configuration, which means launch sites deep inside Iranian territory can still threaten infrastructure across the region. The payload is usually a high explosive warhead weighing roughly 30 to 50 kilograms. That might not sound massive, but against fuel storage tanks, aircraft hangars, radar installations, or electrical infrastructure, it is more than enough, especially when dozens arrive at the same time. But the story becomes more complex, because in recent months, analysts have reported modifications to some of these drones. In particular, cooperation between Iran and Russia appears to have accelerated changes to the Shahed platform. Russia has used large numbers of similar drones in the war in Ukraine. There, engineers experimented with new navigation systems, improved engines, and heavier warheads. Some intelligence reports suggest modified variants may carry additional sensors or enhanced payload options. There have also been discussions about integrating other lightweight weapon components into drone systems, though the exact configurations remain unclear. What is clear is that the platform is evolving, and every iteration becomes slightly harder to stop. But technology alone does not explain what is happening across the Gulf, because the real power of these drones is not individual capability, it is quantity. Iran has reportedly launched more than 2,000 drones during the recent escalation across the region. Many of them were intercepted. Fighter aircraft, surface-to-air missiles, and helicopters have destroyed large numbers in the sky. Footage has even shown attack helicopters firing chain guns at incoming drones over the desert, but the strategy does not require every drone to hit. Even a small percentage reaching their targets can create serious disruption. A single drone, igniting a fuel tank near one of the busiest airports in the world, can halt aviation traffic across an entire region. And that is exactly what happened. Authorities temporarily suspended flights at Dubai International Airport after the strike caused a large fuel fire near the facility. The blaze was eventually contained. No injuries were reported. But the message was clear. These drones are not designed to win battles. They are designed to disrupt entire economies. But the real question remains unanswered. If these drones are slow and relatively primitive, why are advanced air defense systems struggling to stop them all? The answer lies in something far more dangerous than the drone itself: the swarm. Modern air defense systems are designed to stop extremely fast weapons, ballistic missiles, cruise missiles, high-performance fighter aircraft. But the Shahed drone attacks something very different. It attacks the defender attention. Because the true weapon is not a single drone. It is the swarm. In a traditional missile strike, a defender might face 5 missiles, perhaps 10. Air defense radars detect them. Command centers calculate trajectories. Interceptor missiles launch. Within minutes, the threat is neutralized. But swarm drone warfare changes the equation entirely. Instead of 10 targets, defenders suddenly face 100 or 300. Or in the recent escalation across the Gulf, potentially thousands of incoming drones launched across several days. And every single one must be tracked. Every single one must be intercepted. Because even one reaching a fuel depot or airfield can cause major disruption. The physics of the drone itself actually works in its favor. A Shahed drone flies low, very low, often only a few hundred feet above the ground. This creates a major problem for radar systems. Ground-based radar works best when tracking objects high in the sky, but when a drone flies close to the terrain, hills, buildings, and even the curvature of the earth can partially hide it. Radar operators call this ground clutter. The signal becomes mixed with reflections from the environment, which means the drone can appear and disappear on radar screens. The second challenge is speed. Ironically, the drone's slow speed can actually make interception harder. Modern air defense missiles are optimized for fast threats, missiles traveling at several times the speed of sound. When a slow propeller drone approaches at roughly 180 kilometers per hour, tracking algorithms sometimes struggle to classify it as a high priority target. And that delay matters, because every minute lost reduces the reaction window. But the most serious problem is economics. Air defense is extremely expensive. For example, a modern interceptor missile can cost hundreds of thousands or even millions of dollars. Meanwhile, a Shahed drone may cost only tens of thousands depending on the variant and production method. This creates what military analysts call the cost exchange problem. Imagine firing a $1 million interceptor missile to destroy a drone that costs $30,000. Now imagine doing that 50 times in one night, or 200 times. Eventually, the defender runs out of interceptors, or simply cannot afford to keep firing them. And that is exactly the pressure swarm tactics are designed to create. Recent data from the Gulf conflict demonstrates this clearly. Hundreds of drones have already been launched toward Gulf states since the escalation began. One report indicated that more than 500 drones were fired at the United Arab Emirates alone during the early phases of the conflict. Air defenses intercepted the vast majority, but even a small percentage reaching their targets can still cause damage. In one early wave, roughly 6% of incoming drones managed to impact infrastructure despite interception efforts. That may sound small, but if 1,000 drones are launched, 6% means 60 explosions across airports, ports, power stations, fuel depots, and military bases. This is why the March 16 attack near Dubai International Airport was strategically significant. At around 4 in the morning local time, a drone struck a fuel tank near the airport, igniting a large fire and forcing authorities to suspend flights. Dubai International Airport is one of the busiest aviation hubs on Earth. More than 95 million passengers passed through the airport in a single year before the conflict. Even a temporary shutdown sends ripple effects across global aviation. Flights are diverted, cargo shipments are delayed, insurance costs rise, and airlines lose millions of dollars, all caused by a single drone. But the economic disruption is only one layer of the strategy. The psychological impact may be even greater, because drones create uncertainty. Missiles arrive quickly. The threat is visible. The strike happens. Then it is over. But drones can take hours to reach their targets. They may fly across several countries before impact, which means entire populations spend hours waiting, listening for the sound, that distinctive buzzing engine. A sound Ukrainian civilians began calling the flying moped during earlier drone wars. Now imagine hearing that sound not once, but dozens of times across a single night. Air raid sirens, radar warnings, explosions in the distance. Even when defenses intercept most of the drones, the psychological pressure continues, and that pressure spreads beyond the battlefield. It reaches financial markets, shipping companies, airlines, energy traders, because the Gulf region is not just another battlefield, it is the center of global energy infrastructure, which means the real target of these drone swarms may not be the military at all. It may be the global economy. And if that is true, then the next phase of this conflict could be far more dangerous than a single burning fuel tank. The burning fuel tank near Dubai International Airport was extinguished within hours. Flights gradually resumed. Emergency crews contained the damage. On the surface, the crisis looked manageable, but military planners around the world were not focused on the fire. They were focused on what the attack revealed. Because the real significance was not the explosion. It was the method. A swarm of inexpensive drones threatening some of the most heavily defended infrastructure on Earth. And that signals something much larger. The arrival of hybrid drone warfare. For decades, military power depended heavily on expensive platforms. Fighter aircraft carriers, long-range bombers. These systems required enormous investment, training, maintenance, complex logistics networks. Only a handful of countries could afford them. But drone warfare has begun to change that balance, because drones dramatically lower the cost of precision strike capability. A single Shahed drone can travel hundreds of miles and hit a specific target, without a pilot, without a runway, without risking a multi-million-dollar aircraft, and most importantly, without risking human life. That makes them politically easier to use, and strategically harder to deter. Iran is not the only country exploring this model, but it has become one of the most aggressive developers of drone-based warfare. Over the past decade, Iran has invested heavily in unmanned systems, surveillance drones, armed drones, loitering munitions, and long-range strike drones. These systems have been supplied not only to the Iranian military, but also to allied groups across the Middle East. That network dramatically expands the number of potential launch points. Instead of one country launching drones from its own territory, attacks can originate from multiple regions simultaneously, which complicates detection and response. The cooperation between Iran and Russia has also accelerated drone development. During the war in Ukraine, Russian forces used large numbers of Shahed-type drones against Ukrainian cities and infrastructure. That battlefield experience generated enormous amounts of operational data: engine reliability, navigation accuracy, countermeasure resistance, flight profiles. Each wave of attacks created new information for engineers, and that information feeds directly into the next generation of drones: improved guidance systems, better satellite navigation receivers, enhanced electronic resistance, and potentially larger warheads. Every improvement increases the drone's effectiveness, and every improvement spreads across global drone markets. But the strategic implications extend far beyond the Middle East. Military planners in the United States, Europe, and Asia are now asking the same question. What happens when drone swarms become even larger? Because the number 2,000 is already staggering. But future conflicts could involve 10,000 drones, or even more. Manufacturing these drones is far easier than building fighter aircraft. Factories can produce hundreds each month, and once mass production begins, numbers grow quickly. That means future wars could include sustained drone bombardment lasting weeks or months, instead of isolated attacks. Defending against that scale of threat will require new solutions. Traditional interceptor missiles are simply too expensive for large drone swarms, which means militaries are now investing in new counter-drone technologies. Directed energy weapons are one possibility. High-energy lasers can destroy small drones almost instantly once they lock onto a target. And unlike missile interceptors, a laser shot costs only the electricity required to power the system. Another solution involves electronic warfare. Many drones rely on satellite navigation signals such as global positioning system guidance. If those signals are jammed or disrupted, the drone may lose its ability to reach the target. Some systems are already capable of forcing drones to crash or fly off course. But even these technologies have limitations. Lasers require clear atmospheric conditions and line of sight. Electronic warfare may not work against drones using advanced guidance systems or pre-programmed navigation. And swarm attacks create another complication. Even if defenses destroy 95% of incoming drones, the remaining 5% may still reach critical infrastructure, which means defenders must achieve nearly perfect interception rates, night after night, wave after wave. That is the real challenge revealed by the attacks across the Gulf. Air defense is no longer just about stopping missiles. It is about managing saturation. Too many targets, too little time, too many directions, too many launch sites, and every incoming drone forces defenders to make a decision. Which target is most dangerous, which target must be intercepted first, and which threat might slip through. This changes how wars escalate, because drone attacks allow countries to apply pressure without immediately crossing the threshold into full-scale war. A drone strike can disrupt airports, damage oil infrastructure, or ignite fuel storage tanks. But it does not necessarily trigger the same political response as a large missile barrage or airstrike. That ambiguity creates a dangerous gray zone, a space where conflict can intensify gradually without clear boundaries. And that is why the events surrounding the Dubai fuel tank fire matter far beyond a single airport. They reveal a new battlefield reality: cheap drones challenging billion-dollar defense systems, small engines threatening global supply chains, swarm tactics reshaping military strategy. This is not just a regional problem, it is a preview of future warfare, because the next major conflict may not begin with fighter jets crossing borders. It may begin with a distant buzzing sound in the night sky, a sound that signals the arrival of hundreds of small drones. And once those swarms appear, stopping them may be far harder than anyone expected.